Welcome to solverfy.
Question number 58 tells us that a point source is emitting light uniformly in all directions at an average rate of p naught with a frequency f. So this is going to be a general derivation, and we want to show eventually that the peak electric field E naught is going to be equal to mu naught times C times P naught divided by 2 pi r squared. And the hint reminds us that the surface area of a sphere is pi r squared, which is very helpful, but I don't think we had forgotten that, now had we? The thing that we need to note is that the light, since it is a point source, has the same intensity in all directions. So we can use that spherical symmetry and geometry to use with our equation for the average intensity, I bar, which is just peak power divided by A. And we know that, thanks to the hint, the A is 4 pi r squared. And that is equal to 1/2 times C times epsilon naught times the peak E field. And in the final answer here, we see that we have a mu, which is related to here, which is related to epsilon naught. So since we're looking for epsilon naught, let's solve for it by the following relation. So epsilon naught is equal to 1 over c squared mu naught. So epsilon naught is the permittivity of free space, and mu naught is the permeability of free space. So we're going to plug in here for that, and we see that we have 1/2 c 1 over c squared mu naught, not h, E naught and that is squared, and it's all equal to, again, p naught over 4 pi r squared. Okay, well, one of these c's goes away, and we want to solve for E naught, so we move these to the other side and take the square root to get finally mu naught times c times p naught, all divided by 2 pi r square. And luckily, that seems to match up with what we wrote earlier.